Hello, everyone. Thank you for joining our session on DevSecOps. I'm Hariharan Suresh, a Senior Solutions Architect with AWS. So today, I'll walk you through the agenda for this session. So we will be talking about how to protect your web applications or any applications with setting up effective DevSecOps pipelines powered by AWS. Next, we will walk you through about the common application patterns, which is beneficial with DevSecOps pipelines and the stakeholders involved with it. Finally, my fellow solutions architect, Ife, will take us through a DevSecOps demo on AWS. Before getting into DevSecOps, let's talk about the stakeholders of DevOps, predominantly developer group as well as IT ops group. So the key goal of developers are going to be changing the system very frequently, doing a lot of experimentations for the business to be supportive. Next, the IT ops team don't want to have multiple changes. They want to keep things for business as usual. So the factors of both developer team and ops team is going to be very different, and their goals are going to be different. In most of the scenarios, the security team will kick in at the very end of DevOps pipeline, setting up their compliance codes for the total project. What kind of problems does this approach bring to the table? We are seeing a rising number of data breaches, security issues with this approach, and this is growing every day. Companies and organizations are spending a hell of money, time, and energy to sort out all these problems what their ops teams are facing. So let's check this thought process with some data points. According to a survey, which is conducted by Sonatype, we see the software supply chain attacks has been on a rise 6-fold since 2020 to 2021. This is very alarming. Next, the Linux Foundation has conducted a survey which denotes 98% of the projects are using one or many open source solutions. It can be third-party packages, or it can be the full-fledged solutions. Whatever it is, but it is 98% on any and every project what organizations are developing. Next, to put things into perspective of these two data points, every single open source package is having a known vulnerability for 81%. This is a very big number. So this proves that we need to have a security scrutiny for whatever applications we are integrating with our DevOps pipelines. Now let's take a look at the DevSecOps philosophy. DevSecOps is achieved by integrating and automating your security goals or controls within your DevOps pipeline. The security controls can be preventive, detective, or responsive in nature. And this is going to be different based upon your project needs and your design of your DevOps pipelines. If we include security in DevOps very early in your developer cycle, then all of your team's work can be factored within your engineering efforts. Secondly, the security-specific technical debt can be accounted. So currently, the security efforts may or may not be added to your engineering efforts. Moreover, the third important aspect what we need to think about is all of your team will get a fair bit of idea on your compliance needs and your security end state. So additionally, the engineering team's decisions will be very inclusive of your goals regarding compliance. So you can define your project success criteria, setting up your DevSecOps story. Next, for strengthening your application security, we need to adopt shift-left strategy with your DevOps. The security due diligence should be started at very early stages of your development. So in this slide, basically, you can see a broader aspects of security cutting across your CI/CD pipelines. The security assurance can be integrated at various stages. To name a few, config management, key management, authentication and authorization, your encryption policies. So every single piece of security has to be factored during your development stages. As we have gone through the DevOps process, here you can see a frequent application patterns being used at organizations. Most of the organizations has a combination of different applications based upon their application type, their development states, the teams involved in multiple stages. To name a few, you have development teams, you have testing teams, you have infrastructure administrators, finally you have security teams. So all these 4 teams are going to be like working totally together to pull up the new feature releases. So let's pick up very hot topic, application pattern, which is microservices. The microservices-based applications involves active development across functional teams. So all these teams are going to like work in tandem. So this application can move rapidly between different stages and different teams. And once till it reaches a maturity state, these changes are going to be inevitable. Secondly, let's take a look at monolith applications. The monolith applications may have a longer deployment time. So we need more downtime compared to microservice architectures. Still, the application need to be less secured. We need to ensure protecting our data, what we are operating with these applications. So, to protect data breaches, the development and operational practices has to be very similar to your microservices applications also. Finally, let's talk about legacy applications. Most of the companies will be having some legacy applications out there, which will be in maintenance phases mostly. Still, infrastructure security need to be ensured if you are going to expose this application to internet user base. So, all these 3 kinds of application patterns are going to be like workable at the same stipulated time in any given organization. Let's talk about components of DevSecOps. We spoke about DevSecOps processes, practices, and different application patterns. But how to enforce DevSecOps? We are talking about the processes here. So we have to enforce DevSecOps in 2 stages. First is security of the pipeline. The second stage is going to be security in the pipeline. To take an example of security of the pipeline, the access mechanisms of your pipeline has to be like controllable through identity access management and roles and segregation of duties. The next tenet for security of the pipeline is going to be your detective and preventive controls. Who is doing what and what is being executed. If we have audited information of these details, then you are going to be more in control of your DevSecOps pipeline. Finally, the data operated within your total pipeline has to be encrypted at transit as well as at rest. Next, let's talk about security in the pipeline. The security in the pipeline is a hot topic. It has 4 stages. The first stage is going to be protecting your sensitive information. So all the access keys, database passwords, your URLs, everything has to be like securely stored across your different environments. So your DevOps pipelines can have like testing stages or QA or production. So all these environments will have very different infrastructures to be like deployed with. So protecting sensitive information is a key important factor to like secure your total assets. For this, you can think about using AWS Secret Manager or Parameter Store if you are using AWS services. And if you are going to like have open source mechanisms, then you can think about Docker secrets or GitHub secrets. Secondly, let's talk about software composite analysis. A software composite analysis process can be identifying the vulnerabilities of third-party packages of any open source packages what you're going to like put in use. One famous open source tool which we can use here is the OWSP dependency checker. So if you are having Java-based developments, so this tool can be very handy. So this can identify publicly disclosable vulnerabilities. And AWS provides Amazon Inspector, which is automated machine learning powered vulnerability service, which is easily integratable with your Git repositories. Next, I want to talk about static code analysis tools. So we can have static or dynamic code analysis tools integratable with your DevSecOps pipelines. This helps to perform automated security scanning of the codes written by your developers and highlight vulnerability issues. So before the code goes to production and expose any sort of issues, you can mitigate it in your development cycle in an automated fashion. And there are certain tools which can actually educate your developers to use best practices. So for example, if you have dependency leakages or resource leakages, so it can actually help us to do best practices codes. SonarQube is one of the tools which can help to check quality gates and automatically analyzes the code and detect bugs in your codes. You can use Amazon Code Guru Reviewer and Profiler. So Reviewer can help you to do this automated analysis. Secondly, Profiler can help you to figure out which is the most expensive code block in your deployments. So you can only focus on that piece of code rather than going through all your codes. Third, to automate your provisioning of your total pipeline, we need to think about an infrastructure as code tool. You can have two options here. You can completely codify your security requirements within your infrastructure code. So for that, you can use AWS CDK, which is Cloud Development Kit. If you use Cloud Development Kit, you can make use of any programming language your developers are comfortable with, and you can completely write your infrastructure as code. The other option what you got here is AWS CloudFormation. So you can create JSON or YAML files to define your infrastructure constructs. We have spoken about multiple pieces of securing your DevSecOps pipelines. Finally, after the deployment is over, we need to have a proper observability chain to understand what's happening within your pipeline. The observability of pipeline can be enabled with a group of tools. Amazon CloudWatch can help you with collecting and storing your application logs. Then, if there is any sort of problems or anomaly happening within your logs, we can use alarms and metrics to notify your team. Secondly, to understand your operations of developers within your AWS infrastructure, you can audit their operations using CloudTrail. Finally, if there is any problems happening, you can use a simple notification service to send an email to your team to notify them about the problems. Now, I would like to call upon my colleague, Ife, to show us a DevSecOps demo powered by AWS services.
Hi everyone, I'm Yifei, Solutions Architect based at AWS Singapore. So today I will give you a quick demo of how we can shift left by using various AWS services with all the security components integrated in our CI/CD process. So this is the architecture of the demo that I'm going to show today. So as a start, I'm going to talk about deployment. So the AWS Cloud Development Kit, CDK, is one of the infrastructure as code tool that you can choose to use. So it speeds up your deployment into your AWS environment. And you can choose all the preferred programming language, such as Python, TypeScript, or many other. And I will start by showing how I use CDK TypeScript by simplifying all these to deploy all the resources in my AWS account. So first, I will deploy a simple Python Flask app just for demo purpose with our serverless container service called ECS Fargate. My image will be stored in our Amazon Container Registry, ECR. And then after that, I will show a quick demo about how I perform a blue-green deployment as well. And let's see all this in action. So I define all my code with CDK TypeScript. And it will then auto-generate a CloudFormation template for me, and with all the required permissions. So it will proceed to deploy in my account, so I can just sit back and relax and wait for it to complete. And after everything is successful, I'll be able to find all the resources in my CloudFormation stack. And if we go to my load balancer DNS, now my web app is up and running. So that's just a quick show of how we can quickly deploy using CDK. Let's go through a little bit of what's under the hood. So with my CDK sample code here, I have my container service associated with load balancer, ALB. And it has two target groups, which I need it for my demo of blue-green deployment later. And I have some health conditions checked here. And now you can see the blue target group is actually routing all the traffic to my Python Flask app right now. And I have another green target group, which when I push for a new deployment later, it will perform the health check to ensure that the new environment is healthy and ready for me to route traffic to. So for the deployment configuration, here I set a 10% of routing per minute. And there's also some of the definition of how I set up my CI/CD pipeline using CDK here. So you can see the different stages that I have defined here. And as the next part, I'm going to demo a blue-green deployment. So I'm using all the code services that Hari has explained to you just now, such as code pipeline, code deploy, and also some of the security services, such as Code Guru and also ECR and HunScan. For those who are unfamiliar, for blue-green deployment, what we'll do is we'll create two separate identical environments, and I identify them as blue and green group. So my current version of app, which is the Python Flask app, will run on my blue group, and the new version is going to run on the green one. And once I complete testing all my new environments, I will slowly route my traffic to the new one, and after all the traffic routing is successful, I'll shut down my old environment. So with blue-green deployment, what I'm going to do now is I'm going to switch my Python Flask app to a new version of my app called WebGoat. And why I choose to do this is because WebGoat is actually an open source app. It's deliberately designed to be insecure. So now we can see how the different security services that I've included in my DevSecOps pipeline is able to detect and pick up some of this. So back to my demo. Now I'll push my code, WebGoat app to my code commit repo. I've actually enabled Code Guru scan behind it, so it will scan through my code after I push, and upon successful, it will trigger a new pipeline process. So we can see now a new pipeline process has been triggered, and it will auto-transition to the build phase. So in my build phase, we can see the details of the build runs. So if you want to investigate with some logs, you can do so as well. And in here, you can actually add some of the preferred tests that you want, such as unit tests, integration tests, and others. And before we proceed to the deployment phase, you can also add a manual approval steps. So if you want someone, a reviewer, to reject or approve before you are deploying to your production environment, you can set up using an SNS to notify the reviewer when it's ready to review. So in my case, I actually auto-trigger the deployment after the build is successful. And when the deployment starts, now you can see what it happens. It will create two separate identical environments as shown here and start performing the health test. So the ECS will start two new tasks running my WebGoat app now. And the target group will actually start performing the health test. And after the health test is successful, we'll be able to see that it proceeds to the next step. So the traffic routing will start, and because I specify 10% per minute, you'll be able to see it real time here. 90% is still going to my old Python app, and 10% to the new one. And here it will show you that my target group is actually reflecting the same. And just to skip some waiting time, there's a cool dashboard here to show you it in real time. After everything is completed, it will shut down the old environment. And my ECS is going to stop the old task running my Python Flask app. And if we go to the target group right now, we'll be able to observe that the green target group is routing all the traffic to my WebGoat app. And if I go back to my same web URL, now my WebGoat app is appearing right now. Now, we know that's the ideal case, right? Everything fails all the time. So what if there's issue or error happening during my deployment? So in my CDK setup, I've actually included some setup to auto-trigger automatic rollback in case anything that fails. So I track using CloudWatch alarms by tracking some of the metrics. So for a simple scenario here, I'm going to change my landing page. So after changing the landing page, similarly, I'll push and all the same pipeline process again. But when we arrive at the deployment phase, the ECS will start 2 new tasks, as you can see right here, with the new version. And same thing here, target group will start the health check, and as expected, it will fail the health test. And after the health test fail, it will start the draining process, and ECS will actually stop the unhealthy task. And all these are tracked by my CloudWatch alarm. Now it's triggering my CloudWatch alarms based on the conditions that I set, and it will trigger the auto rollback process. And now when we go back to my web URL now, so luckily my WebGoat app is still up and running. So showing you this is just to let you know that you can, with all these ECS and code deploy capability to perform automatic rollback setup, you can actually have a peace of mind and not to risk your user experience while deploying to your production environment. Now that's all about the deployment and blue-green deployment. So let's deep dive into our security aspect. So I have integrated a lot of the security services here. But let's start with the first step, where I first push it to my code commit. And I've enabled Code Guru Reviewer to scan my code. And setting up Code Guru Reviewer is very easy. You can just have it with a few clicks. There are multiple source providers for you to choose from. And in my case, I'm using Code Commit. So I can choose the repo and branch that I've been pushing to and associate it with Code Guru and let it run the scan. And before showing the result, I want to show you this OWASP top 10 security list. So we have some of the common ones that we have always been hearing, such as leaked password, credentials, or SQL injection attack. And why am I showing you this? If you remember why I choose to show you switching to a WebGoat app is because it has many insecure code design in it. So now we can review if some of the security services is able to pick some of this up. And this is a sample analysis of my run using the WebGoat app. And I'm going to search through some of the top vulnerabilities here. So I'll start with SQL injection attack. It will filter through some of the recommendation lists that Code Guru has picked up. And clicking into it, it will bring me directly to the exact line of code that it has identified in my repo. And another example here is showing the hard-coded tokens and credentials. And not only those, Code Guru is able to identify some of the inefficient code as well, such as resource leak. So with all this benefit, you can see that your developer teams can actually catch all these errors or problems early and fix them before they reach the production environment. So another example, you can easily enable image scan after we push our image to our repository. So Amazon ECR has offered basic and enhanced scanning. It uses common vulnerabilities and exposure, the CVE database from open source CLAIRE projects. And with enhanced scanning, ECR actually integrates with Amazon Inspector to provide both OS and programming language package vulnerability scan as well. And similarly, setting up is very easy. You can do so via CLI and console. And after you enable, it will scan through all your repo, or you can set some filter through some of the repo. And looking into some latest image push scan, you can view it directly from the ECR console itself, or clicking into it, it will also integrate it to Inspector, where you have all other consolidated findings from other resources as well. And can view it by different aspects, and clicking into it, it will show you a lot of the details here, such as remediation fix, and also the details of the vulnerabilities from the source. And for this instance, the enhanced scanning has actually picked up some of the critical vulnerabilities. That's from WebGoat, that's using web server client that's outdated. So we urgently need a fix now. So that's all for demo 1, which I'm using mainly AWS native service. If you remember what Harry mentioned just now, many of you have been using some of the third-party or open source tools, and you don't want to change some of that. You can achieve similar results with using your existing tools as well. And I've built another simple scenario to show you here. I'm using GitHub Actions as my CI/CD tool instead. And for security aspect, instead of Code Guru, I'm using the SonarQube scan now. And at the end, I'm also having a Lambda function that I define and pick all these SonarQube scan results and push everything to AWS Security Hub. And to set up GitHub Actions, there's a starter workflow template that can make your life easier. So from your GitHub repo, you can search for it and use the default template directly. You just need to replace your environment and account details, and you can use or customize according to your needs and commit it to your GitHub repo. And this is the sample successful run of the default template. And in my build, I'm using SonarQube with all the token and credentials stored in Secrets Manager and Parameter Store, and my Lambda function pushed to Security Hub. And this is the sample of that build runs. And if you see here, there's actually integration that is fixed with my GitHub repo. And there's a webhook event here that's responsible for triggering all these actions to happen whenever I push to my GitHub. And a quick show of SonarQube scan result here. So there's a dashboard for you to view. It's similar to what I showed you in Code Guru just now. It picked up blocker critical issues, and it has also detected some of the high priority issues, such as hard-coded credentials, SQL injection attack, and with all the details. And because I've pushed everything here to my Security Hub, we can find all this in my Security Hub now. And with all the details as what I defined in my Lambda function. And showing you this, it means that Security Hub doesn't just have my SonarQube scan result. It also includes many other resources. These are the AWS native ones, but if you have third-party security tools that you have been using and you choose to import it to Security Hub, it will show it here as well. So that's all for my demo part. We have covered a lot today, and just a quick wrap up. We are just showing some of the potential services and mechanisms that you can leverage to build a DevSecOps pipeline for your team without sacrificing their speed. And by baking all these security mechanisms into various steps of the CD process, you can achieve many benefits as stated here, such as reducing risk or save you some costs as well. And here are some of the resources that we have covered today. If you're interested, scan the QR code to find out more. And also, if you are interested, you can visit our Skills Builder Center to find out a lot of the free resources, courses, labs, and games to learn at your own pace. Thank you again for attending. So we really appreciate your feedback. So please do take some time to complete our survey so that we let us know what you think. Thank you very much.